Hey guys, we are going to continue talking about the number of ways an event can happen, and we'll start today with mutually exclusive events. Mutually exclusive, there's no order, and once you make a choice, all other possibilities are now excluded. So mutually exclusive means one or the other, not both. Okay, when you see this word or, that's a key word that tells you it's mutually exclusive. Okay, so for an a mutually exclusive event, the number of ways A can happen plus the number of ways B can happen. If there's a third category, you would add the number of ways that C can happen. So Mr. Fonfara has a class of 24 students, Mr. Hill 18, Mr. Hutchinson 31. In how many ways can we choose a student from Mr. Fonfara's, Mr. Hill's, or Mr. Hutchinson's class? So there's our key word, or. This is mutually exclusive. Mr. Fonfara has 24 plus Mr. Hill's 18 plus Mr. Hutchinson's 31 students. Okay, so we're going to add up those numbers. So we've got 24 plus 18 plus 31, and that is 73. So there are 73 ways to choose one student from one of those classes. A bin at Walmart contains DVDs, 16 comedies, 11 dramas, and 7 educational. In how many ways can we choose 4 comedy, 2 drama, and 3 educational? This one's going to have multiple steps to it. This is a complex situation. Okay, so first, we need to figure out how many ways we can select within each category. Does order matter? We're choosing, but we're not ordering, we're not arranging, so no, order is not going to matter. So I'll make a note, there's no order. And when there's no order, that tells us combination, not permutation. Okay? So to figure out the number of ways we can choose our comedies, we're going to choose 4 comedies out of 16. So we're going to use that NCR. N is the total number. In this case, that is 16 comedies. And we're choosing 4 of them. Okay, now in the previous lesson, we used a formula to find out how many ways we could choose those 4 out of 16. We wanted to actually see the math behind what's happening, but now we're going to use a calculator to figure out that number of ways. Okay, so under the math button in probability, option 3 is NCR. And we're going to go back to the home screen, and we're going to type in 16, which is our N, and then we're going to go to math, probability, option 3, and we're calling up NCR, and then a 4 for R. And there are 1,820 ways to choose the 4 comedies. Okay, so this is for comedy. Okay, next up is drama. We're going to choose 2 out of 11 dramas, so that's 11 C2. So 11, math, probability, option 3, 2. 55 ways to choose our 2 drama. And then 3 educational DVDs out of the 7. Okay, so that would be 7C3. So 7, then math, probability, option 3, and we're choosing 3 of those. 35 ways to choose 3 educational DVDs. Okay, now we're going to find out how many ways these can all be chosen together. Okay, so we're choosing 4 comedy, 2 drama, and 3 educational. And tells me it is not mutually exclusive. If it was an or, we would be adding these numbers. and we are multiplying these numbers. 1,820 times 55 times 35. Okay, so there are 350,350, 3,503,500 different ways to choose. In how many ways can we line up 7 DVDs? So now we're going to take 7 DVDs out of the bin and line them up. Now when we say line up, that means order matters. And when order matters, that's a permutation. Okay, so we're doing a permutation where R is 7 and N is the number of different DVDs. So there were 16 comedies plus 11 dramas plus 7 educational. When I add that up, I get 34 different choices. So it's 34P7. Okay, so I can put that in the calculator, 34P7. So I get 2.7, and I'll just round to 2.71 times 10 to the 10th power. Okay, now I'm going to write out the actual number also. So this is scientific notation. I'm going to put it in standard notation. That's 271326464. And that's moving the decimal 1, 2, 3, 4, 5, 6, 7, 8 places, 9, and 10. So I'm just going to double check where I had 0.71 times 10 to the 10th. I'm moving 10 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are that many ways to line up 7 DVDs. Given the word radio, in how many ways can these letters be arranged? So if I was to mix them up, how many different ways could I do it? Here's one way. They can be aligned in that order, but we can rearrange them in any order we want. How many different orders? Okay, arranged is a permutation. So order matters. We're going to do P. There are 5 letters, and we're going to use all 5 of them. So 5 P5. 120 different ways. Okay, I'm going to show you another way that we could solve this. When we want to use the letters in a word, there are 5 different letters here. I'm going to make 5 blanks. In the first blank, I could choose any one of those numbers. I've got 5 options. In the second blank, I've used a letter here. Now I only have 4 options left. The third blank, I've used 2 options. Now I've only got 3 left. Now I have 2 left. Now I've only got 1. And if I multiply all those numbers, it's 5 times 4 times 3 times 2 times 1, I get 120. Now when I multiply numbers all the way down to 1 like that, that is the same as doing 5 factorial. So 5, and then math over to probability. Option 4 is factorial. So 5 factorial is also 120. So there's 3 different things I could do. 5p5, 5 times 4 times 3 times 2 times 1, 5 factorial. They all give me 120 ways. Now for B, we've got some restrictions. We're going to rearrange the letters. There are 5 of them. And when there's restrictions, I think using these blanks is the best way to go. R is in the second spot, so I know that's an R. The last letter is a vowel. Okay? Now, there's only one R in this word, so there's only one option right there. Okay, vowels, A, E, I, O, U. There's an A, an I, and an O. 3 of these letters are vowels. I have 3 options for that spot. Okay, now I've placed letters in 2 different spots. Out of the 5 letters, 2 of them are placed, and that leaves me with only 3 options here. Now 2 options here, and 1 option here. And I'm going to multiply all those different options. So 3 times 1 times 2 times 1 times 3 is 18. There are 18 different ways to arrange these letters, given that R is in the second spot and the last letter is a vowel. A car dealer is going to be hiring 2 mechanics, 4 salespeople, and a secretary. 5 people are applying for the mechanics position, 11 for sales, and 3 for secretary. In how many ways can they be selected? Okay, now they're not being put in any particular order. We are just selecting these people. Okay, so this is like selecting the DVDs on the previous page. So we need to know first, how many ways can we select our mechanics? So we're hiring 2 mechanics. There are 5 applicants for mechanics. So that's 5C2. Okay, and it's a C because order does not matter. So it's a combination, not permutation. Then we're going to multiply by the number of ways to choose the sales people. So we've got 11 people applying for sales. We are going to choose 4 of them. We're going to multiply that by the number of ways to choose a secretary. So that's 1 secretary. 3 have applied for that position. 3C1. Okay. Now I can do 5C2 and 11C4 and 3C1 and then multiply those numbers, or I could just put this all in my calculator right now. I'm not necessarily interested in how many ways to choose just the mechanic or just sales or just secretary. I want to know the total, so I'm just going to go ahead and multiply them all at once. So we've got 5C2 times 11C4 times 3C1. And that is 9,900 different ways. Four boys and 3 girls are to stand in a line. In how many ways can they be arranged? So we've got 7 people here, and all 7 of them are going to be arranged in a line. Arranged, permutation. Okay, so we are going to arrange 7 students, and we're going to use all 7 of them. 7P7. And that is 5,040 different ways. Okay, and I could have done 7 blanks, 7 options, 6, 5, 4, 3, 2, 1 to get that same number of ways. I could also have done 7 factorial. Okay, now we're going to have some restrictions. How many ways can they be arranged if a boy is in the 2nd and 5th spot and a girl is in the 4th spot? Now I think the blanks is the way to go. Okay, so in the 2nd and 5th spot, there's a boy. The 4th spot is a girl. There are 4 boys, so for this first boy spot, I have 4 options. Now that I've placed a boy, for this second boy spot, I only have 3 options. There are 3 girls, so for this spot with a girl, I have 3 options. At this point, I have placed 3 students. There were 7 total, so that leaves me with 4 options, 3, 2, and 1. And now I'm going to multiply all of those numbers. Okay, so we have 4 times 4 times 3 times 3 times 3 times 2 times 1, 864 different ways. Row A has 5 students, row B 6, and row C 1 student. In how many ways could we choose 2 students not sitting in row B? So that means the students have to come from these 5 or this 1. Okay, I can't use these 6. We're going to choose, but we're not arranging. So no order, which means it's a combination. Okay, we are going to choose 2 students, so that's our R. And how many students do we have to choose from? We have 5 here and 1 here. That's 6 total students to choose from. So we are going to do 6C2. So there are 15 different ways to choose those 2 students not sitting in row B. In how many ways could we choose 2 students coming from the same row? So I don't care what row they come from, but they're going to come from the same row, which means they have to come from row A, row B, or row C. This is a mutually exclusive event. Okay? So that means we're going to do some adding. So we need to find the number of ways we can choose these students from row A. Okay, so it's 2 students from row A, which has 5. And we're going to add how many ways we could choose these 2 students coming from row B, which has 6, plus the number of ways to choose 2 students from row C, which only has 1 student. Now, there's no way to choose 2 out of 1, so I know there's going to be 0 ways to choose those. Okay, 6C2 is 15, which I already had in my calculator right there. And 5C2 is 10. So there's 10 ways to choose these students from row A, 15 from row B, 0 from row C. 10 plus 15 plus 0 is 25. There are 25 ways to choose 2 students who are going to come from the same row.